wabarakatuh. Good morning and warm greetings to all distinguished participants. My name is Rizka Amalia, and it is great honor to be your Master of Ceremonies for today's webinar on PRIMA's talk from Regional Climate Downscaling in CORDEX, Southeast Asia to Climate Impact Assessment, Advances, Gaps, and Collaboration Opportunities this Thursday, October 9, 2025. It is a great pleasure to welcome you all both those joining us via Zoom and on BRIN Indonesia YouTube channel to this virtual gathering this morning. Allow me first to extend a warm welcome to all of you who have joined us this morning. We are honored by the presence of Professor Fredolin Tentang from University Brunei Darussalam as our speaker for today's webinar. To our distinguished moderator this morning, Mr. Yuda Setiawan Jamil, PhD, a senior researcher from Research Center for Climate and Atmosphere BRIN. And to all the esteemed participants joining us today, welcome and thank you for your presence. Ladies and gentlemen, to begin today's event, let us stand and solemnly sing the Indonesian national anthem, Indonesia Raya. Trouble. Okay, sorry. I think have trouble with the song.
Yes, please continue, Mama.
Okay. Okay, ladies and gentlemen, before we begin our main agenda, now we will be taking a picture together. So please, sir and madam, please activate your camera and video function on your Zoom meeting. And I would like to invite the committee to help us with taking a group photo. Okay. This is have 2 slides. Ready? For the first slide. 1, 2, 3. Don't forget to give your best smile. Okay. The next slide. 1, 2, 3. Okay. I think enough. Thank you, everyone. And the next, ladies and gentlemen, unfortunately, Mr. Alberto Sulaiman, who's slated to open our webinar today, is unable to join us. Therefore, we will move straight to the next item on agenda. We hope that on another occasion, Mr. Alberto Sulaiman will be able to join us. Okay. Ladies and gentlemen, we now proceed to the discussion and presentation segment. Moderating this session is Mr. Yuda Setiawan Jamil, PhD, a senior researcher from PRIMA. Good morning, Mr. Yuda.
Good morning, Mbak Amel. Thank you for the introduction. Thank you for opening the forum.
Yes.
Good morning, everyone, ladies and gentlemen, friends and colleagues. Welcome back to PRIMA's talk, our scientific dissemination forum for a very comprehensive and well-accomplished discussions. And we always have a distinguished guest as speakers, and nowadays is very special because our speaker will be Prof. Fridolin Tanggang, a well-known climate scientist, not just in our region, but globally. And Prof. Tanggang now hold a faculty position in University of Brunei Darussalam. And we know him previously in University Kebangsaan Malaysia, UKM. But then there's a recent news. He's also appointed as emeritus professor in the UKM also. So I think it's as testimony to his dedication and achievement in climate science. And allow me to break down a little bit based on my point of view, because the first time I met Prof. Fridolin is during a symposium in KL on 2006. So it's 20 years ago. And since then, I follow his work and learn a lot from his work, especially in doing a variability study on rainfall and all the weather analysis. And somewhere in, I think 2013, 2014, he has a publication, his students, on verification, model verification, global model verification. And I start to understand that Prof. Tanang also embarked on a future projection kind of discussion. And not long after that, we get the news on the establishment of CORDEX Southeast Asia. And that will be, nowadays, we know CORDEX Southeast Asia could be the most impactful project on climate projection in our region. We know Prof. Tanggang as one of the initiator, one of the founder, together with a lot of senior researcher in the region, including our own climate guru, Pak Edwin Adrian. And a lot of climate studies in Indonesia has relied on our CORDEX project, and some of the conclusions, some of the results from the CORDEX project remain relevant until today, despite of various high resolution projection product or other methods to do a climate projection. And nowadays, CORDEX has went through the next phase. So this, what's the future of CORDEX? This is one of the things that Prof. Tanggang is going to share with us, because we understand it is very important. The future of CORDEX might define the future of our region, our country. And in addition to that, Prof. Tanggang would also share his other research interests, including maybe his new research interest in his new position right now in Brunei. So, ladies and gentlemen, friends and colleagues, please join me to give a warm welcome to Prof. Fridolin Tanggang in PRIMA Talk. Please, Prof. Tanggang, the floor is yours, sir.
Thank you, Dr. Yuda. Thank you, BRIN, for inviting me to this opportunity, PRIMA Talk. I met you recently in Singapore AOGS, and I think that was the the beginning of idea for this talk, and alhamdulillah, it is realized now. When you are at the last mile of useful days in the academic life, in this age, sometimes you forget what has been transpired in the last like 20 years or so. So I was amazing that your narration there even remember like 2006. So thank you so much. Yes. Let me just share my slide. Yes, my today's talk title is kind of mixed. So I will be talking a little bit about CORDEX and so on. But more importantly, I think especially now at the BRIN platform, in my mind, BRIN is such a huge organization in Indonesia. It's not just talking about we're not just talking about climate science, but also impacts. And when it comes to climate action, of course, when it comes to climate policy, climate projection is just one part of it. And scientists from all kind of expertise have the responsibility to help the stakeholders, especially government, in devising robust and informed policy making processes in ensuring that we are going to adapt and increase climate resilience in this Southeast Asia region in our countries, basically. So so these are the gist of my talk, and this is my outline. But first, I think let me just a little bit give a background why it is matters for us to understand climate change, its impact and future risks. And then I will talk about a little bit about the history of CORDEX, what we learned from CORDEX, and still what are the gaps, and how successful are we actually in trying to connect CORDEX into impacts, the idea that I have that I'm going to bring up here, basically, can we collaborate? Can we emulate the the collaboration that we had in CORDEX in the impact sectors, which is, I would say, can be more challenging because of the multidisciplinary nature of impact assessment. You're not just about talking about climatology there, And lastly, I will perhaps highlight perhaps it might be difficult to have a collaborative climate change impact assessment and vulnerability assessment in the whole of Southeast Asia, but certainly I think it's possible in Borneo, given the fact that Borneo, we have 3 countries here, Malaysia, Brunei, and Indonesia. Perhaps it's something that we can initiate. So let me just start with a little bit background of what we know about climate change, and these are basically coming from the IPCC. And of course, within BRIN, you have Professor Edwin. He was actually replacing me in AR6 as a vice chair for working group 1. And then he continued to be the vice chair of working group 1 and AR7. So yeah, but these are the key conclusion of the IPCC. And there are 5 essays that climate change is unequivocal and human influence is clear. But in the AR6, IPCC concluded that climate change in the climate, recent changes in the climate are widespread, rapid, and intensifying, and unprecedented in thousands of years. Short sentences, but really meaningful there. And if we look at last year's, this is the average global mean temperature, as you know, that last year was declared as the warmest years, and it reached 1.55 degree above pre-industrial for the first time. That is quite significant. But if you look at that graph there, it is of course in addition to these interannual variabilities, but the background increase is just keep increasing, and this is likely to be the trend in the couple of years in the future, decades in the future, unless of course the world act in one voice in mitigating climate change. But perhaps the challenges is there, and perhaps we will be the world will be able to mitigate this, but we don't know. And this is why it is important for us to understand the risk of climate change in a particular country, in all countries, so that action can be taken. So in 2019, the temperature was only 1.1 degrees C. Of course, this is the average of 5 years. But even at 1.1 degrees C, this is unprecedented in at least 2,000 years, based on the paleoclimate data there. So this is really, really significant, But it is not only in the temperature, it's not only the temperature, but it's also the changes in all components of the climate system. The precipitation and the glacial mass loss, in the, of course, sea level rise, and also the ocean heat content. So and as you may know, but the CO2 has been increasing since pre-industrial, basically. And if you're talking about each of these, the changes has been unprecedented in not in decades or century, but in thousands of years. For example, the CO2 concentration in the current times considered highest in at least 2 million years. Sea level rise fastest in 3,000 years. Arctic sea ice area, this is considered lowest in 1,000 years. And the glaciers retreat unprecedented in 2,000 years. So everything is in 2,000 years. So we are actually at the Earth climate system at the stage where never seen in thousands of years. So what I have in the left here, this is a graph indicating the CO2 concentration for the last almost 1 million years. What I have on the right-hand side here is the same, but this is coming from the IPCC using the same data actually. In addition, we do have the methane and nitrous oxide. In the middle here, this is a picture where, this is in the Antarctica, where scientists digging the ice core, and exactly that this data actually coming from ice core. It fluctuated. Ice core, you have this bubble air traps within it, and scientists basically able to retrieve this trap airs and directly measures the greenhouse gases, CO2, as well as other potential methane and nitrous oxide. And throughout the 1 million years, it fluctuated. Of course, this is associated with the orbital changes, and this is where you have these changes, glacial, interglacial. But it takes a long time, even from the lowest here into the highest. It takes maybe 20,000-40,000 years, as opposed to what we had in the recent, human influence, which is less than 200 years. It gone from 200, 380, or sorry, 300 part per million into currently about 420 or 430 part per million. So what is important is that for the last 1 million years or so, the natural range of this is just 300, from about 180 to 300 part per million. But human made it, now is outside of this natural range. And of course, if that continues, by the end of the century, we will probably have about more than 1,000 part per million of CO2 in the atmosphere. So those data are coming from the Mauna Loa, the recent one, of course, and some other places. But in your very own Indonesian station, Kota Tabang, in Sumatra, I had a chance to visit this, and they started to measure this in 2006. So this is part of the BMKG station and part of the so-called WMO GAO, Global Atmospheric Watch, where they continuously measure, CO2. You see the trend there is the same, like what is it compared with the Mauna Loa, So CO2 indeed increasing because of the human activities, especially burning of fossil fuels, and temperature has been increasing, and IPCC used this analysis, which is attribution using model, of course. And if model is forced with only natural and forcing, which is solar, and changes in volcanic eruption, it cannot explain this increasing temperature, which is in the black, which is more prominent after 1960s or so. But if human activities are included as part of the forcings, and then the model basically can pick up this increasing temperature, and this is one of the strongest evidence provided by the IPCC, that the current warming is basically human influence, and even so that IPCC was able to calculate that the total human influence in the warming is actually matching well with what has been observed in this particular period here. So in the AR5, and of course in the AR6 as well, IPCC concluded that the Earth climate system was in the so-called relative imbalance since 1970s. So what does it mean by relative imbalance? Is that what's coming in from the solar is about the same, but what's going out of the climate system at the top of the atmosphere is becoming less and less because of the greenhouse gases. And 90% of this additional heat trapped by the greenhouse gases within the climate system basically absorbed by the ocean. And this is indicated by this data. Yeah, as you can see that the heat, heat content, ocean heat content from around 200 meters, 400 meters or so increasing, and this is real data. This is not simulation. most of these actually come from Argo floats. Perhaps some of you very familiar with Argo float, and coming from many investigation as well, basically. So this is 90% of this heat, additional heat, actually absorbed by the ocean. If the ocean doesn't absorb this, probably the atmosphere will be a lot much hotter. But the ocean, as you know, is an engine of climate system, and eventually it will affect the climate system and making haywire changes in global climate as well as regional climate. So we know that these days extreme heat becoming more frequent, more intense. It's not just in some other part of the world, but in our region as well. Our neighboring countries like Vietnam, Philippines, Southern China have been affected very much in recent weeks due to these typhoons. We have droughts everywhere, forest fires, and of course I mentioned about the ocean is absorbing more heat in sensitive ecosystem like coral ecosystem is going in the brink of collapse. So that is what is happening now, and we don't really care that much about climate change if it's not getting worse. But the fact it's getting worse, that is according to the science provided by the IPCC, and in the worst case scenario, by the end of the century, we may end up like 4 to 5 degrees warmer than the pre-industrial, like what I highlighting here. But when we talk about 4-degree warming, that is the average globally. But if you look at this map, for example, in the Arctic region, it could be like more than 7 or even 10 degree warmer. In fact, currently, perhaps some study shows that in the Arctic region have already reached perhaps 2 or even greater than 2 degrees warming compared with the rest of the average. It's not just temperature. Rainfall will be changing, more drought, of course, more heat waves. And here is indicated the projected extreme rainfall. So you can see that extreme rainfall will be, and this is perhaps because of every degree of warming, there will be 7% increase of moisture in the atmosphere, and because of the moisture that would drive this intense rainfall, and this translate into more flooding and so on in the future. So yes, this is the worry here. Climate change has been occurring in the past millions, of course. In 3 million years ago, the temperature could be around 3 to 4 degrees higher than what in the pre-industrial. 15 years ago, not 15, sorry, 60 million years ago, the temperature was like 15 degrees, and of course, during this period is natural factors. The Earth is still evolving, but the key point is that all this because of the CO2 concentration. But moving forward, if the world follow the worst case scenario, some of you may be familiar with the SSP 8.5. By 2100, it will be a repeat of what we had in 3 million years ago. And by 2300, it will be a repeat of what we had 60 million. The only thing here is that we don't have millions to wait for this. This is within century, within the lifetime of our generation, basically. So we do not have choice but go into that kind of scenario where the temperature will more or less the same like what we have currently, but of course slightly warming here and there. But with adaptation, maybe the world is still livable as compared to without mitigation. So that kind of scary thing can be illustrated by this diagram, where in the past we have this glacial interglacial kind of thing, but human started using machine and starting this unsustainable development and so on, and starting to pump greenhouse gases and steering the earth into this warming trajectory. And we are currently here, and we will continue be into warming the so-called hot house if nothing is being done. So the thing is that we need to go into this, put the earth within livable condition here, as opposed to going into this so-called hot house. So that is the challenge, but looking at those challenges, we need to understand the emission here. So this is the emission diagram, annual emission diagram from the IPCC. And, simple enough to draw a conclusion here is that emission has been increasing for the last 20 years or so. And in 2019, 75 of these emission coming from CO2, and 64% of this coming from fossil fuel in industry, and about 11% coming from LULUCF. Together, it contributes to 75%. So if we were talking about mitigating climate change worldwide, this is an area that we need to look at, how to mitigate climate change, how to reduce the emission. Actually, we do not have choice, because according to IPCC, if we were to achieve 1.5 degree by the end of the century, limit the warming by 1.5 degree, drastic cut of greenhouse gases has to be done. In fact, from that about 60 gigaton CO2 equivalent in 2019, that has to be reached, around 25 to 30 gigaton, which is 50% by 2030, and achieving net zero of CO2 by 2050. If we were to achieve this, this is from the IPCC based on science. But what about the policymakers? What about the action? What about the world commitment now? This NDCs, right? And this is IPCC evaluated this and based on the indices, before COP26. This is like a couple of years ago, like 4 years ago or so. The policy in place as well as the indices is just not enough to ensure that the warming below 1.5. But instead, that will take us into 3 degrees by 2100. And of course, the COP meeting is continuing and so on, but there is no guarantee that the mitigation can fix this problem. And this is why it is important, for us researcher here to translate the projection and translate those two into risk, and then policy maker will take that information in devising inform policies, especially adaptation policies, to increase resilience. So I have already said about how climate change have already been impacting the human and natural system. And that impact will continue, of course, for every degree of additional warming in the future. So all this basically are critical or vital core of human lives. And if these are impacted, human life, of course, will be impacted. So this is a very important diagram connecting what we understand about physical climate change, and how physical climate change will be changing in the future with the so-called vulnerability and exposure of certain sectors, and how these three things will link will define the level of risk. It is the risk that's actually important for policymakers to consider in terms of devising policies, in where to adapt, how to adapt, and in what sectors to adapt, basically. So for South Asia, this is important, and so important that because in Southeast Asia, because of this is a region with high exposure, high vulnerability, and also kind of low adaptive capacity to the climate impacts. So these are some of the images that I gathered from the internet there. In the current climate, but in the future it could be getting worse. We could get photos that are getting worse in the future because of climate change. Indeed, if we use some of these previous studies indicated that the number of extremes in the region increasing, especially flood, and of course Southeast Asia is one of the highest number of natural disasters, of course including climate-related disasters as compared to other regions. So we need policies, and policy cannot be devised out of nothing, cannot be developed, established out of nothing. So if I'm a policymaker, robust science must be in front of me to make informed decision. And hence, I need to know how risk will be manifested in future period associated with this climate change in whatever sectors that particular country thinks that important. But this is the problem lies. This is an assessment carried out. This kind of long, kind of old. This is actually in AR4. Sorry, AR5. I think, I beg your pardon. This should be AR5. Sorry, AR5, not AR6. AR5. Yeah. Where assessment has been carried out by the IPCC to look at whether information is enough in study of impact of climate change for observed as well as projected. And whatever you have this X, meaning that not enough information. And as you can see that for Southeast Asia, for P, which is projected there, it's not much information. And we thought at that particular time, before we established CORDEX, this could be the motivation. This could be associated with maybe lack of climate projection data that impact study can use to translate, into or to assess this risk in vulnerability, But I believe this is still remains the issue, where within most of the countries of Asia, we still lack of information in terms of how climate change is impacting certain sectors, So perhaps not lack of projected information, projected climate information, but lack of research, So but when it comes to, of course, at the regional scale and national scale, GCM simply cannot be used, or GCM is not really appropriate to use given the fact that it cannot really resolve regional scale well, let alone local scale. And Southeast Asia is very, very complex. When you look at the landmass distribution, and a particular GCM may not be able to resolve this. For example, this is a particular GCM for Southeast Asia. The land masses there, the coastline is just look like Southeast Asia, but it doesn't give the details that perhaps a particular country needs, when it comes to using the product from the GCM. We need to downscale this. Even worse for many Philippines, and of course that's the same for Indonesia, where you have thousands of islands. So this is actually giving us some kind of motivation. In earlier speech by Dr. Yuda already mentioned about CORDEX. So prior to 2013, we had no coordinated effort in driving this initiative on climate regional climate downscaling, and of course many countries even until now do not have ability to establish their own climate projection. Is because climate projection needs multiple GCM, downscale with multiple RCM, long period until 2100. If you're talking about high resolution, it's very costly, it's very time consuming, and it has to be carried out in a coordinated and multi-nation collaboration. And this is basically, give us the energy that particular time. And I made an effort to call, a workshop in Hanoi, Vietnam. And as you can see, your very own Pak Ibn was there. And some of colleagues from BMKG was there as well. And the rest are colleagues from countries within Southeast Asia. And I'm not trying to exaggerate this, CORDEX South Asia is one of the success story of many CORDEX domain around the region, because from nothing into something that we can be proud of until today, basically. In 2022, we celebrated our 10th anniversary in Vietnam. So, but CORDEX again is not just CORDEX Southeast Asia. Many CORDEX around the region, but CORDEX South Asia was the last, established, and I provided the leadership of this for more than 10 years, actually, from 2013 until 2023, when we actually, established a proper structure within CORDEX Southeast Asia, So, but CORDEX, sit within WCRP, used to be sitting within WCRPs, different, but WCRP itself evolved, and a couple of years ago they developed this so-called RIPS, Regional Information for Society, and CORDEX basically sit under this, So, but I don't blame you if you are not aware of what this RIPS, because it's still relatively new. But I hope that, as it now, probably they are more visible in Africa and maybe South America, and because of personalities. But I do hope that they will, engaging us in this region to be part of this initiative. But otherwise, if we can continue within this CORDEX platform, not just doing the science, doing the climate projection, but providing this data, and then advance this application, understanding of impact and risk and vulnerability, and advance the networking and capacity building. And if we can do this, even without RIPS, I think we should be fine. So throughout that more than a decade, within CORDEX we implemented these phases. The phase one, we downscale the CMIP 5 GCM into 25 kilometers, and then in the phase two, we further downscale it into a number of sub-regions into 5 kilometers. And then we are currently in the phase 3. We are downscaling that new GCM, CMIP 6. Every domain is doing that basically. But in addition, we do have another project which is downscaling further into city scale, over 5 megacities that include Jakarta, Manila, Kuala Lumpur, Bangkok, and as well as Hanoi, basically. So we learned quite a lot about this project, and this is what I mentioned earlier. We decided to be having this structure, having 2 co-chairs. Currently, we have Dr. Fei of Manila Observatory as co-chair 1, and then Professor Jerson co-chair number 2 from Ramkhamhaeng University. In each of the countries, we have this representation, and this structure make it very, very strong. I would say so, and of course, I remain to be active here as an advisor. So is your own Professor Edwin there. So we are lucky. From day one, we got institutional support from BMKG. Of course, not just from BMKG. We get support from university. But when it comes to national agencies, BMKG is the one that actually been supporting us from day one. And the picture on the left, this is the first time, the first workshop that we had back in 2013 in BMKG there. And as you can see, I'm younger, more than a decade younger. And on the right here, this is a more recent one, more recent picture, where we had a workshop in Jakarta in last August, basically. And this is for the Kepo Megacity. This is where we downscale further into city scale, basically. So this is a very important project because this is where we identified some of the priority hazard, climate-related hazard in the cities, and understand how this will be changing in the future in light of warming climate, basically. And hopefully, because along this, within this project, there will be a component of where science interact with the policymakers. This is the group picture. As you can see, the big picture behind there, basically the Director General of the BMKG, Professor Dwi Koreta, who kindly opened the session. So big commitment from BMKG from day one. But as I said, not just BMKG, but everywhere around Southeast Asia. This is in Manila. We had the RegCM workshop also in Manila, sometime more than a decade ago. We have workshop everywhere in Bangkok, in Vietnam, and this is the last for phase one, where we launched this the portal, climate data portal in Bangkok. We call it Success, basically. So now I'm highlighting a little bit of key finding from the CORDEX Southeast Asia simulation of the phase 1, where we downscale the CMIP 5. And this is the list of model that we had during the phase 1. And this is possible because of not just collaboration within the region, but collaboration outside the region who contribute these runs, And no single country can do this by itself. It has to be through a coordinated and collaborative research, collaborative contribution like this. So this data have been used by some countries, perhaps including Indonesia's, Vietnam, and also Philippines for their national projection, have been used by impact studies. But in my mind, we are still not very far from that IPCC assessment on the table that I mentioned earlier. So a lot more need to be done to connect, climate projection into impact studies, basically. So that data, basically archived in the so-called ESGF node, and through that project, through the CORDEX Southeast Asia, we managed to establish this node. Most of these nodes basically in US, in Europe, but we have one in Southeast Asia because of this project. And this is where we launched this in UCAM in 2018. This is the president of Ramkhamhaeng University came down to our university. This is a deputy vice chancellor of UCAM. And this is where we exchange notes between Ramkhamhaeng and UCAM, where we together basically manage this data center. So what we contributed out of this project is very important for IPCC, and you also some of you perhaps know this IPCC interactive atlas. For Southeast Asia, the data is coming from this CORDEX Southeast Asia. And we published quite a number of publications as well. I lost track of this. This is not updated, but probably around 50 or more than 50 publications. And that's a good initiative, I would say, to increase the scientific understanding of climate over these regions. And this is a partial list of this. Maybe you don't have to read this. So let me highlight what is the key finding here. So this is projected changes of seasonal mean rainfall. We look at 2 seasons, DGF and GGF. And when it comes to the GGF, this is in percentage relative to historical period. So when it comes to the DGF, it is the changes here is this kind of blue here. This is positive, meaning increasing. It kind of increasing over the Indochina there, but everywhere else perhaps a little bit less. Both for RCP 8.5 as well as RCP 4.5. So for those of you who are not familiar, this is the emission scenario used in the AR5 cycle. But for GGA, the key things there is like the reduction of rainfall in the maritime continent, especially Indonesia, during the GGA. So, but if you of course most of you know that during GGS is a drier period over this region, and when you get this color here, it means it's even more drier in the future. But again, it's not just drying is a concern, but it's also wet extremes. But I would like to perhaps point the drying trend here. So so we calculated some indices. This is so-called CDD, consecutive dry days, and this is for the RCP 8.5. Sorry, 4.5, and this is RCP 8.5, and this is an annual scale, annual time scale. So as you can see that over Indonesia's drying, Indonesia, Malaysia is drying, and but if we look at seasonally, according to season, Most of that signal you see the annual coming from the GGR as well as SON, both for 4.5 as well as 8.5. Basically, so you can see here, perhaps around more than 30% or higher than 30% increase in the CDD, consecutive days without rainfall. So I'm sure this has some effect on some critical sectors like water resources, agriculture, and so on. If we plot this according to global warming level 2 degree, you get almost the same thing. People say that that's coming from CMIP 6, and perhaps it's have some uncertainty and not really robust. But there is a recent result from CCRS Singapore groups, and they also look at these CDDs for this season. The signals are almost the same. So I'm actually very confident that because of climate change is drying tendency in our region. But when you average this over 20 years, you eliminate the interoperability, meaning that in the future this is going to be like every year occurrences, But we know that this kind of phenomenon, this kind of drying here, is already occurring in the current climate during El Nino. Okay, during El Nino. So in the future, because of the way you average this, it means in the future we will like perhaps having like El Nino every year. Condition like in this drying, in this part of the region, And of course, I myself have done, a lot on the interoperability, including El Nino. This is our work with Pak Supari. Pak Supari, some of you knows, in offices at BMKG when he did his PhD in UKM back in 2018 or something or earlier. This is we look at all kind of things. The one that I'm showing here, basically the increase of CDD during El Nino, earlier season, GGR, SON, and so on. But let's pay attention to these two seasons, GGR and SON. So you can see that whenever you have El Nino, you have the entire Indonesia basically experiencing increase in CDD, dryness. We know that, and that also carry into SON. And this, of course, a challenge when it comes to forest fires and so on. And this is also the case for Malaysia. And I believe Brunei is also impacted. Drying trend during El Ninos. So even in the current climate, we are already experiencing this, basically. But the projection says that in the future, even without El Nino, we will experience something like this. Not only once in every year, a couple of years, but every year, because of climate change. But the bad news is that, the El Nino is getting stronger in the future and getting more, and this is result by Wenju Chai and groups in CSIRO Australia, where they indicated when they plotted the observed El Nino here, they can see this pattern, right? And emerge this extreme El Nino here, 1982, 1970, 1997, 98. So when they look at the model during the period of 1891 until 1990, they can replicate that pattern, But when they plot this from 1991 to 2019, this red dot here is like twice more than this red dot here. What does it mean? It means that extreme El Nino in the future becoming more frequent. So that really bad news, because without El Nino in the future, every year we will have El Nino condition drying pattern. But El Nino is also will be there once in every year. And here it says that extreme El Nino will becoming more because of global warming. But it's not just that. The recent projection from CCRS here indicated that the heat wave is there as well. The heat wave becoming a daily occurrence. For example, the worst case scenario here, this is in terms of the frequencies. You get this color here. So over Indonesia, Borneo, less over Indochina. This is like 200 over. So meaning like every day will be heat waves. So here you're talking about duration days, right? Of the El Nino is more toward Indonesia. In the magnitude there, 4 to 5 degrees. If we go into 8.5 by the end of the centuries, basically. So nothing is good news for us when it comes to climate change. In the current climate, we're experiencing drying associated with El Nino. In the future, without El Nino, we will be experiencing the same kind of magnitude of drying every year. But not only that, we have more extreme El Nino, and of course, we have heat waves. So that's not really a good news. But the good news here is we have lots of data. So those are, whatever I highlighted to you earlier is coming from the CMIP 5. Some people said that CMIP 5 is already kind of outdated. I agree. But we do have CMIP 6 here. And this is the current one that we have. This is almost 100% completed. Lots of data to play around. This is 25 kilometer. But we do have also from Singapore, CCRS, and this is 8 kilometer for the entire Southeast Asia region. In fact, bigger than CORDEX Southeast Asia. 8 kilometer. And 6 GCM, but of course they only have one RCM and 3 scenarios. But if this will be part of CORDEX Southeast Asia data as well. This will be archived in CORDEX Southeast Asia, and success I mentioned earlier. So plenty of data for us to translate future climate change into impact, into risk, into vulnerability of all sectors required by the government. So this is something that important to be done. We as a scientist, I think we have responsibility to do this. So why is it crucial to understand the risk and impact of climate change in the future? Because this will inform adaptation and mitigation planning, of course. This will strengthen resilience, limit climate change impact. With this, we can target mitigation measures toward most vulnerable regions and communities. And most importantly, this support NAP, National Adaptation Plans, so that it is going to be evidence-based and effective in reducing long-term climate risk. It's not just you come up with this NAP out of nothing. So it supports climate resilient development as well, which is part of going into this livable world. So when it comes to Southeast Asia, this is the time. This is the time that we have this data. The question is, can multidisciplinary scientists, because it requires multidisciplinary scientists to approach this. Because of if you're talking about risks that involve vulnerability as well as exposure, those are basically multidisciplinary scientists. Climate scientists like me will not be able to do, but we are providing this data, projected data, basically. So can multidisciplinary scientists work together in assessing climate risk and vulnerability in South Asia in a coordinated way, and emulate CORDEX South Asia success? Can scientists in this region work collaboratively to find robust finding, provide robust finding on climate risk to help government in policy making process? This is our responsibility, basically. So I have an idea. It's not easy for Southeast Asia. Despite similarity, we do have diverse, differences. But for Borneo, I think this is workable because in Borneo we have only one country, 3 countries, and Borneo, as I showed earlier, basically one of the hotspot when it comes to climate change. And a couple of months ago, we had already some kind of initial discussion among a few colleagues from Sabah, Sarawak, Kalimantan, and some other places within Indonesia and Malaysia. Maybe we can have something like this, using this climate projection and use those climate projection in addressing some of these, impact and vulnerability risks in environment, ecosystem, food securities, in health sectors or something. Now, in Brunei, we do not have choice. Perhaps even 25 kilometers is rather very close. Even 8 kilometers is still very close. So we are in the process of proposing to Brunei authority to support their NAP and informed policy decision process to downscale further. In doing so, perhaps we need to downscale into 2 kilometers within Borneo and then maybe 1 kilometer within Brunei. But if we can do this, at least for Borneo, if we can do this together with, collaboratively with Malaysia and also Indonesia, and then come up with this coordinated risk assessment and vulnerability assessment research initiative involving these 3 countries in apply joint international funding and work collaboratively. And then, our government will be very, very happy, I think. I cannot speak on their behalf, but this is what they are looking for, basically. So this is my last slide. I did not watch my time, but hopefully, I'm still within the time frame. So let me just go through a little bit here. Climate change or global warming really at the verge of reaching 1.5 degree. It has reached 1.55, but that's because of we had El Nino in 2024. But WMO said almost like 80% this is going to be reached in the next 5 years, I think, if I remember that correctly. I still think that Southeast Asia's lack of research on climate change impact, risk, and vulnerability assessment to guide informed policy making, especially NAP. But we are at the stage where we have data, and we spend decades in building up this capacity and within the region to come up with this. If we don't use this now, we will miss the opportunity. Perhaps we can come up with a collaborative and coordinated way, the way we do in CORDEX, Southeast Asia, in doing this collaborative work on the assessment. But I can warn you that it's not easy to gel people of this multidisciplinary expertise to work on a common goal there. But we can start with Borneo, and we can start Borneo, and hopefully we can realize this, and hopefully I can come back to that group that I initiated earlier. So that is my last slide, Pak Yuda. Thank you so much.
Thank you, Prof. Tanga. Very inspiring talk, and also very intriguing ideas that has been delivered to us today. And we have like 45 minutes towards the end, and we will use this for a Q&A. And as a moderator, I'll use my privilege to pose the first question, probably for Prof.
Yeah, sure. Yeah.
I have a question regarding the model resolution, because we understand that we want to have a high resolution model output given the complex boundary condition of our regions. However, if you look at those results coming from CORDEX, those drying in the south and higher rainfall at the north, it's more like more of a large scale kind of features instead of smaller features within the region. So does the high resolution serve for the impact study per se instead of the climate change analysis, where the larger scale probably already sufficient to say a lot of things about the climate change and the future of the climate in this region? So can I have your opinion on that?
Well, I mean, perhaps when it comes to what kind of data required by the impact side, maybe I'm not the right person to answer this. Some people say 25 kilometers is still not enough for me to for them to drive their impact model, hydrological models, and so on, and addressing issues related to health and so on. Certainly for Brunei, for example, I would say even 8 kilometers is still not very fine enough, and this is why we are keen to provide much high resolution. It is also good science for people like us to do this basically. And along the way, we will be able to develop capacity building here in terms of climate modeling, and this is what we want for Brunei. And for Indonesia, of course, because of you have many islands and so on, this should be the case. I would say perhaps in some locality, the 25 kilometer from CORDEX or 8 kilometer from Singapore CCRS may not be sufficient to do this, and perhaps BRIN can initiate some kind of. I know you have a capability in terms of human resource scientists there, as well as in terms of computational resources within BRIN that can be used to further downscale, and the boundary condition to force this certain area, small domain, can be gathered from CORDEX run. Basically, CORDEX run can be used input. So some sectors, maybe 25 is fine, maybe 8 kilometers, but some sectors maybe requires more. They want to have a specific map, for example, in terms of breeze, in a particular area, rather detailed maps. And I understand this is the case for Brunei. Brunei is rather relatively small countries. So it's a good science. In my mind, we want to basically develop this capacity within Brunei. It's not just for Brunei, but if we have this capacity, Brunei in the next cycle, for example, can contribute to CORDEX as well, can contribute to the region in providing this. It's not just these 5 countries. Only 5 countries are contributing within countries within Southeast Asia. Only 5 countries, which is Malaysia, Indonesia, Thailand, Vietnam, in the Philippines. So Brunei certainly have resources perhaps to do this, but we need to build up capacity. And I understand Brunei will also be hosting the ASEAN Climate Change Center. It's supposed to be within the university very soon. And it's good if Brunei have a capability to contribute to ASEAN countries in terms of climate projection in the future.
Thank you for the answer, Prof. Tan. Okay, I give it to the floor. Anyone with a question can raise their hand, or maybe write in the chat box, and we can read out your question. Please, have question for Prof. Tan.
I have a question.
Okay, please go ahead, please.
Okay, regarding very interesting topic what you explained for us, I have 2 questions maybe. First question is, how can CORDEX Southeast Asia data support early warning system for floods, droughts, as well as heat stress at the national and transboundary scale? That's the first question. And the second question is, which sectors in sequence, right? For example, water, agriculture, health, and infrastructure are most vulnerable to projected climate changes according to CORDEX Southeast Asia data? That's my questions. Thank you.
Okay, good. I think very important question there. So the first one, I think we need to understand and differentiate between early warning system and climate projection. So early warning system often referred as forecast rather than projection. So projection is you kind of forecast of climatic condition in a long horizon time scale, but this is dependent on the what if scenario. Okay, this is why we have this emission scenario. So it is most useful for it to provide the science in terms of influencing the policy making process, long-term planning, and so on. And of course, having early warning system, it could be a result of this. If in the future, for example, you identified or the risk of impact in certain sectors is indicated in the projection. One of the no regret education measures is to have an early warning system. Basically, you need to develop this early warning system. And CORDEX Southeast Asia data is not meant for that. Okay, CORDEX Southeast Asia is not meant to that.
Okay.
So you have to distinguish between climate projection and climate forecast, real climate forecast. Now, question number 2, which one is important? People like me, again, I cannot answer this. But this is the answer that we will get if we translate this climate projection data into impact and risk within each sectors. And to do this is not people like me. This is a multidisciplinary kind of initiative, which involve, if we're talking about water resources, it has to be hydrology, it has to be, to some extent, I think social scientists will be relevant in all sectors. So the answer to your question is, and this is something that we are interested, and we, all of us as a scientist here, we are having responsibility in driving meaningful research in understanding future risk, future impact of climate change, so that policymakers understand this. When they make decision, all this, the science will be in front of this. And this is what we call making decision based on robust science, evidence-based kind of approach, basically. So we don't have the answer, but we together should be working toward providing this answer.
Okay.
Okay, Pak Arif, any follow-up?
Yeah, that's clear. That's clear
Okay,
explanation.
thank you, Pak Arif. Thank you. Okay, any other question for Prof. Tangan? You can please go ahead.
Thank you, sir, for the
Thank you.
First of all, I would like to ask some question. The first thing is about the IPCC AR5 and AR6 climate risk paradigm or climate risk understanding. Is there any paradigm shift? Is there any paradigm shift in the AR5 climate risk and the AR6 climate risk? Because As far as my understanding, in AR5 climate risk understanding, risk is defined by sensitivity, exposure, and adaptive capacity. But in the AR6 climate 6, maybe the baseline risk is only defined by the impact. Because in my understanding, the more easy to digest is the AR6 because the risk is defined by how far or how much, maybe how far the certain sector is impacted by the climate risk, other than how far each of the climate risk components such as sensitivity, exposure, and capacitive adaptivity response. So is there any paradigm shift in the climate risk understanding? And then the second question is about, maybe IPCC and a lot of country that are part of the Paris Agreement, adopted the Paris Agreement, and there is many voices about climate-proof infrastructure. My question is there any guidelines of how to adopt the climate-proof infrastructure so any country could follow, and what are the climate variables that we need to address if we want to make a climate-proof infrastructure? I think that is my question, sir.
Thank you. Wow, difficult question. Well, let me answer the first one. The first one is about this IPCC framework for risk assessment. But before I answer that one, most of you knows Professor Rizal Dibo. He is also champion of this risk assessment. In fact, he has written one paper together with your own Professor Edwin, I think, on risk. So risk is something need to be considered when it comes to adaptation, because even climate change is there. If the risk is low, perhaps we don't have to do anything at a local scale, right? We still need to mitigate, but when it comes to adaptation, maybe we don't have to do anything because the risk is low. But having said that, it's up to the policymakers. Policymakers must be provided in front of them at their disposal all these signs, right? Now, whether there is a paradigm shift from AR5 to AR6, I don't know, maybe a little bit. I don't really pay attention this much, but the way IPCC work. It is basically based on reviews of literatures. If there is a little bit of change, that is because in the scientific community something is changing a little bit. But I would say it's still, when it comes to risk, climate projection is important to understand the hazard, and the vulnerability is important, and the exposure is important, and of course you mentioned adaptive capacity, which is part of it. Question number 2, very specific for infrastructure. This is, I don't know. What need to be included in there. You need to have an expert on this to give a comment on this. I would say so. Right. So, but when it comes to infrastructure, my layman kind of answer to that question. Often like flooding is a disaster that can, have great impact to infrastructure. So engineers need to understand this also. You cannot just base on written period of the last 20 years or 30 years data, because what's in the future, your 100 years certain period is perhaps no longer 100 years certain periods, because of climate change. And extreme rainfall is definitely increasing because of ability for the air to hold more moisture, and rainfall rainfall intensity becoming more increasing in the future. So I think this need to taken into account when it comes to designing infrastructure in the future, basically. But this is again not just infrastructure, in all sectors. So if we can have this research it's even better if we can do this in a coordinated manner. Not as easy as CORDEX, where we speak in the same language. But if we're talking about many sectors, we are not talking the same language. Multidisciplinary, we're not really taking, if we talk something like this, some other sector don't really understand what we. So it's challenge there, but it's not impossible. This is why I'm proposing. Perhaps we can demonstrate this in Borneo. We do have a projection for 25 kilometer in 8 kilometer, perhaps good enough, but we want to drive this into like 2 or 3 kilometer over Borneo, and that will be very good for Borneo, and of course for Brunei, perhaps maybe if the resources is there, we would like to go for even higher, because Brunei is small countries, So I'm really excited if some people within BRIN very much like this idea and start thinking about how can we collaborate, how can we apply for joint funding and so on. It's possible. It's not like 10 countries, only three countries here.
Okay, thank you, Prof. Tagang. So, Pak Renaldi, is it okay? You want to follow up?
Thank you, sir,
Also?
for the answer.
Okay, thank you, Pak Renaldi. Okay, let's continue the Q&A session.
Pak Edi,
Okay, go ahead, Pak Edi.
terima kasih. Thank you very much, Professor Tanggang.
Yeah,
Oh yeah,
Pak Edi, I know you and
long time
even your
ago.
voice. Even if I don't see your picture, I remember
No,
your
no,
voice.
I had trouble with my camera. I'm very
Oh, okay, it's
sorry.
okay, it's okay.
Yeah, again and again for your nice presentation. I always miss your nice presentation due to the global warming. I have some, maybe opinion or suggestion. First one is the main problem of our government is we are very worried since more than 2,000 small islands Indonesia will be disappear. No future. Nothing in the small island. More than 2,000 islands suspected will be disappear. I don't know when, but suspected maybe 2030 or 2045. Recently, more than 115 small islands will disappear. So, for us, Jakarta, just for only one sample, Jakarta Sing. I hope combination between CORDEX C and CCRS P3 can be used at least to predict, at least to make the scenario more than 2,000 small island will be disappear. What do you think about this, Professor Tanggang? First one, about more than 2,000 small island. It is possible
So
using CORDEX.
yeah, you asking about sea level rise, of course.
Yeah.
This is really a concern. I did not really talk so much about sea level rise, but it's always been our mind that it should be our mind, of course, if we're talking about future climate change impact, especially in countries with coastal region, and that is the case for Indonesia. That is the case for Malaysia. That is the case for Brunei, and in many other countries within Southeast Asia. We have only a few countries that landlocked, do not have coastal areas. So sea level rise is a concern, and especially if it's in combination of the so-called sinking due to various reasons. And you do have this in Manila, you do have this in Bangkok, in Jakarta, in Bangkok, and as well as Manila as well.
Yeah,
that
that's
will
right.
exaggerate the sea level. So I don't know where is this coming from. Could be credible. You mentioned about 2000. But again, when it comes to sea level rise, it is not just the mean sea level rise that we worry. It is the extreme sea level that is also need to be understood. Extreme the sea level rise is like the mean sea level rise, but what you experience in once a while and so on could be dependent on the weather and climate, which is keep changing. So there is a component of the actual extreme sea level, which is of course the tide. The tide is astronomical, that doesn't really change. That can be calculated easily if you have a long time record, or otherwise you can use estimated data and so on. But it is the component, the storm surges and the wave that need to be worked out. And you need to have a model, wave model. You need to have a storm surge model and the ocean model to look at this, to estimate this. And for Brunei, we are thinking of doing this as well, because Brunei is also having coast, not as long as like Malaysia or Indonesia, but this is one of the priority for Brunei government. So we are going to propose to Brunei, government modeling to estimate this sea level rise estimate you can get from the IPCC model. This can be, you can get this by IPCC, but it is a local changes on storm surges and as well as on the wave, which is a function of climate, because the wind is keep changing in the future. That need to be estimated. So sea level rise is a challenge for us. So I think again, on the same principle, we need to provide robust science to our stakeholders, policymakers, in order for them to make decisions. We cannot blame them for not doing the right thing if we don't provide them the right information.
Yeah, but the main problem is, I suspect the contribution from sea level rise is not too big, just a small one, but the most contribution coming from the land subsidence. Combination of sea level rise and land subsidence is very important. Unfortunately, we don't have much data about land subsidence. So, what is your suggestion?
That could be true. That could be true for Jakarta.
Yeah.
And of course for as I mentioned, it's not Bangkok as well as as well as Manila, basically.
Okay.
But again, we forgot that we are not policymakers, So I think our job is stop at providing information to them for them to make a decision. But if despite our hard work in providing the information, if they're not taking action, perhaps we can blame them. But unless we provide this information, perhaps we should not blame them for now and start working as a researcher and providing whatever information that needed for them to
Yeah.
make decision.
Yeah. And one more serious problem is how we can save our food security from the long dry season or a long wet season. In this here, you mentioned about the impact of El Nino, but I think it's more secure when El Nino and IOD coming simultaneously together, because the impact will be more secure if combined, if only El Nino only, I think. So we need to consider IOD impact also, because IOD is relatively close to Indonesia region than El Nino in the Pacific Ocean.
Agree. I just give
Yeah,
one
yeah.
example there.
Yeah.
I cannot show everything. If I show everything, then we will never stop talking here.
Yeah.
Yes, IOD is important, and whenever IOD co-occurred with El Nino, the impact is basically much higher. But I can draw an example where this kind of research is useful. I remember in that paper that Pak Supari and me and some other colleagues have written, including Pak Ibin is co-author that paper. We came up with some kind of a map to draw, when El Nino occurs, how many % of rainfall, CDD increase and so on. So, you don't have to even focus El Nino, because this is, you cannot focus everything. Some other people will do it for you. We know that when it comes to El Nino focus or Ido focus, some other capable institution around the world, in the US and so on, I'm not really sure now, but we do have centers around the world to provide focus for us. So if we know this, let's say 6 months or a year earlier, that's already early warning system, right? So yeah, I mean, not only El Nino, but IUD is important, and so is MGO and so on. And some of these mechanism, this is a natural way of Mother Nature delivering, climate impact to us, But the thing is that when you add more moisture and so on, things will be changing, and I think I have read papers so that in the future, it's getting more IUD, more MGO in the future is delivering this rainfall basically. So earlier you mentioned Borneo vortex and so on, and in Brunei and Borneo here we do have squall line, especially during this season, and it's a good science question, research question to understand how these squall lines will behave in the future. How would Borneo vortex will behave in the future? We do have answer for big like typhoon and so on. Typhoon becoming stronger in the future, but I don't think we have answer for like squall lines in Borneo vortex yet. Maybe there, I'm not really sure, but this is something a good question to research on.
Okay, Pak Edi, do you have more question, Pak Edi?
I hope I answer your question, Pak Edi.
No. It is about an international collaboration. I think BRIN is open. BRIN is very, very open to an international collaboration. But unfortunately, we don't have an in-situ observation. We don't have. How we can contribute?
Yeah, I mean that is a challenge for not just BRIN, perhaps but when we perhaps when it comes to observation, especially in Indonesia, meteorological organization is perhaps mainly BMKG, and collaboration can be part of BMKG maybe.
I see. Yeah, should be.
You know, but in addition to that, I think within BRIN itself, because BRIN used to be coming from different organizations, right? And even rainfall, as I understand, there are many rainfall gauge that did not belong to BMKG, but belong to some organization that joined to become BRIN, before. But of course, this is an issue that we should look into, especially working in Borneo, for example. So we must have access data to observe data and so on, in trying to validate the model and so on. We do have product like satellite product and so, but even then we need to also validate with observed data to boost our confidence of the
Okay.
of the
Okay. Yeah.
of the satellite data.
Okay. In the last, I would like to mention basically, recently we are very interested about the extreme event. Yeah. For example, Bali floods. Bali floods recently, the impact is very, very secure, very, very large. The other one is Jakarta floods, March 2020 this year, and Bali October this year. So extreme event, I don't know. Also in the dry season, some area is very, very sensitive because of the, yeah, we cannot predict precisely, for example, typhoon, for example, Rosby, Elvin, and combine of so we hope by CORDEX, by CCSW Singapore, and combination of them can be used at least to monitor, to give early warnings for us. Yeah, we hope.
Yeah.
So
Again, if I can comment that, Pak Edi, when it comes to CORDEX product and CCRS product, these are long-term climate projection. It's not really meant for short-term early warning system. That's coming from whatever prediction we have in a national scale, or if you don't have that, perhaps you need to devise one. But welcome to the real world of climate change. I think we are already there. When you see this unexplained, extreme event in the middle of dry period, we have flooding and so on. So that's characteristic of extreme in the warming world. According to IPCC, of course, this getting even more critical in the future when temperature get beyond 2 degrees, 3 degrees, and so on. So there is no guarantee that we cannot stop this warming. I mean, there's no guarantee that we can stop this warming because of the world, how the world function now, especially one particular big country that is no longer subscribing to the science of climate change in pulling everything, right? So we don't know. This is why perhaps adaptation at the local scale is important. And we cannot drive this adaptation at the local scale unless policymakers understand, because they are the one who making decision into what need to be done and so on. It's not us. It's not us. We can making noise and so on, but it is not us that making decision. But we can provide science to them, work together with them, in toward achieving solution in this adaptation. And again, as I said, this projection comes with uncertainty. Perhaps some no regret option is feasible in good enough in minimizing some of the impact that you've seen, like what you've seen in Bali recently.
Okay. Again, thank you very much. Thank you very much.
Yeah, thank you for the nice
So,
question,
Pak
Edi.
Yuda, shall we start to make a nice collaboration Indonesia, Brunei, and
Yes, that's
Malaysia?
the plan, Pak.
Should be Singapore also because Singapore has power for that.
Okay, thank you, Pak Edi.
Thank you very much. Terima kasih Pak.
Ya, terima kasih, Pak. Sorry,
No,
I was speaking too much English here.
no, it's okay. Sehat. Ya,
My
sehat.
English also not perfect,
No, you are better than me. Pak Yuda, terima kasih. Pak Tanggang, terima kasih.
Okay, we
Thank you,
have
Pak Edi.
yes,
Ya, sama-sama.
10 more minutes towards the end of our session, but so let's move on. Next question from the audience for Prof. Tangang.
Yuda,
Please
Pak
go.
Yuda.
Yes, Bu Elsa, go ahead. Bu.
Oh, Bu Elsa, finally you're there. Bu Elsa, how are you?
Fine,
I
Pak Fred.
mistaken someone else as you earlier.
Thank you very much for interesting presentation. I always remember what Pak Fred said, that a climate model must be used by various sectors so that they become very useful. Am I
Yes,
right?
indeed.
We have already used the CORDEX model, the 24-kilometer resolution for impact studies and agriculture, and I realized we need more higher resolution for impact assessment. As you mentioned before, that since 2023, CORDEX will focus to develop a resolution for the CORDEX. What about the progress for the higher resolution development of CORDEX? We know CCRS V3 have released the 8 kilometers. My point about that regarding you focus in Kalimantan, your plan to focus in Kalimantan.
Okay.
We know in Kalimantan, settlement, agricultural area spread over on relatively small area. Not like in Java where the agriculture is more condensed and in large area. For Kalimantan, we need a more higher resolution for impact assessment. How about the progress? And my second question maybe, Pak Yuda, we can collaborate with Prof. Tanggang to develop research in Kalimantan, especially in impact assessment, more focus in a certain area because we know Kalimantan is a very large island, and we can develop collaboration, Pak Yuda, with Prof. Tanggang. Thank you, Prof.
Thank you, Ibu Elsa. So I met you everywhere, in UKM and Singapore. So good question. But you mentioned about CORDEX plan to go high resolution. As far as CORDEX is concerned, we are still at this large domain, 25 kilometer, because going into much high resolution is not within the capability of modeling groups within CORDEX Southeast Asia. So some sectors 25 kilometer is good. Some probably need high resolution. I agree. But CORDEX simply cannot provide this. But again, we have alternative, which is coming from CCRS V3, which is 8 kilometer. The only thing is that although they have 6 GCM, they have only 1 RCM. Meaning that they cannot capture uncertainty from RCM. But if you combine this all with CORDEX, I think that's good. But if we are thinking about a specific area, now because of my interest in Borneo, if we think about Borneo, if 8 kilometers not enough, then maybe we should combine our resources in the way we do in CORDEX for the downscalers. Not every model, but maybe a selected model, maybe 3 models or 4 models, within our capability, and derive this into 2 kilometer, for example, or 3 kilometer. And for Brunei, it's always been the case. The aim is to have 1 kilometer. If we have, we can do this, and then I think Brunei government will be very, very happy. It is possible. In my mind, it's possible because when I started CORDEX Southeast Asia, nothing is there. Some group, small group, they have one machine doing this small simulation for writing papers, but not like this. Not like this. So we developed CORDEX over 10 years. We progressed, build up capacity. Each group getting funding from their government, machine, and so on. Now have capability to do this, and we have this data. And if we don't use this data, and then it's not justified the hard work of scientists in producing this, basically. And some more, we would not be able to influence government in terms of what should be done at the local scale in terms of adaptation and perhaps mitigation as well. So we want to be part of this, basically. And of course, you are expert on food securities. It is something that we already discussed within the initial discussion that we have. And if we can implement this, apply, join, coordinate this, maybe we cannot do this the whole island, but maybe some case study in Kalimantan, some case study in Sarawak, in Sabah, and in Brunei, then maybe we can join force and establish networking and capacity building within this, basically. This is the intention, basically. And who knows, 10 years I'm still alive, and if we can build up this, I'll be very, very happy. Thank you, Boyza.
Thank you, Pak Fred.
Bu Elsa, maybe
Sudah?
we can ask back to Bu Elsa. So what's the requirement for your impact study regarding the model resolutions that you probably can share with us, and also where is the regions that you had in mind in Kalimantan that you are interested to study for this, for your like food security topics, Bu Elsa?
Yeah, our focus area in Kalimantan, South Kalimantan, Pak Yuda, because most of agriculture area located in South Kalimantan, and South Kalimantan is very specific with swampland area. The projection for agriculture production in this area is the research is still limited in South Kalimantan. I am very interested to develop research in South Kalimantan for agriculture regarding the projection. And as mentioned by Pak Fred, we need more higher resolution because the agriculture area in South Kalimantan spread over a small area, not like in Java. So we need more higher resolution for impact studies.
So does like the 8 kilometers from CCRS, is it not small enough, the resolution? You need higher than that, is it?
we should try first, yeah.
Okay.
Use DCCR.
Yeah, that's what we call
filtering.
low-hanging fruit approach. You know, use whatever available you have.
Yeah.
But again, if we can collaborate on this high resolution over Borneo, then I think that will be very good. I don't think that expensive. The 2 kilometer, we can even perhaps try slice run, so-called slice run. And that is possible. And also, nowadays people go to all these kind of AI kind of thing. We also very much interested in exploring this.
Okay. Thank you, Prof. Dolin, the answer. Bu Elsa, you have more follow-up or because now it's already 12 here in
Yeah, I'm kind of hungry. It's 1 o'clock here.
1 p.m. 1 p.m. in Brunei, I think. So at the end of our session here, and I think more question can be addressed to Prof. Tanggang through probably emails, probably. Prof. Tanggang,
Sure.
you may share with us your email, probably.
Hopefully,
Yes.
this is the beginning and not the end. So hopefully, some ideas and so on can as I said, multidisciplinary collaboration can be difficult, but we can use Borneo as a test bed because Borneo has 3 countries. So maybe we can collaborate within Borneo and apply some possible funding and so on, and do it emulate what we had in CORDEX. I think that would be very good if we can do this.
Thank you.
So hopefully we can follow up with this idea.
For sure, Prof. So I think we are at the end of our session here. We would like to thank Prof. Tanggang for very inspiring and intriguing talk and discussions, and definitely follow up will be there towards some real concrete collaboration in the future. Maybe Prof. Tanggang, just a quick writing on your email address, probably in the chat box, so everyone can.
Okay. Let me just email here.
The chat
This
box
is my
there.
email. My Gmail easier.
Sure.
Yeah.
Okay, there you go. You
Yeah.
all can, the audience can take notes. And
Right.
of course, this webinar session is in YouTube Live. You can watch it again and maybe take notes, and some question can be addressed again to Prof. Tanggang through emails. Thank you again. Thank you so much,
Thank
Prof.
you so
Tanggang.
much. Thank you for the opportunity. I
Thank you
think
for
it's
the time, everything.
great opportunity, great discussion here.
Thank you so much. I'll return the session to our MC, Mbak Amel. Please, Mbak Amel.
Okay. We would like to thank Mr. Yuda and our speaker, Prof. Fredolin, for bringing
Thank
us
you.
a productive session today. So, ladies and gentlemen, we have now reached the end of today's event. Lastly, a final reminder for all attendees, please remember to fill out the attendance list using the link provided by the committee in the chat box. It is time for myself and the organizing committee to take our leave. Sorry if there are things that are unpleasant. Have a great day and see you in the next PRIMA talk. Wassalamualaikum warahmatullahi wabarakatuh. Thank you, everyone.
Thank you. Thank you.
Thank you,
Bye.
Pak Fred. Thank you so much.
Thank you so much.
And,
Thank you so much.
keep in touch for all
Yeah.
the.
Well, we should follow up.
Thank you so
Okay.
much, everyone.
Bye-bye. Take care.
Assalamualaikum.